platform in JUnit. Now we are focusing on platform. The JUnit platform serves as a foundation for launching testing frameworks on the JVM. It also defines the test engine API for developing testing framework that runs on the platform. Furthermore, the platform provides a console launcher to launch the platform from the command line, and the JUnit platform suite engine for running a custom test suite using one or more test engines on the platform. First class support for the JUnit platform also exists in the popular IDEs. See IntelliJ IDEA, Eclipse, NetBeans, and Visual Studio Code, and build tools. Check like Gradle, Maven, and Ant. Here you can see a dependency diagram. In org.junit.platform, you can see JUnit platform test kit, JUnit platform suite, JUnit platform suite engine, JUnit platform suite commands, JUnit platform suite API, JUnit platform runner, JUnit platform JFR, JUnit platform launcher, JUnit platform console, JUnit platform reporting, JUnit platform engine, JUnit platform commands. As an Maven example, we can consider this segment. Here you can see group ID org.junit.platform, JUnit platform. As a Gradle example, we can consider this one. IntelliJ IDEA supports here IntelliJ IDEA Gradle additional Gradle dependencies. IntelliJ IDEA supports running tests on the JUnit platforms since version 2016.2. Or note, however, that it is recommended to use IDEA 2017.3 or newer, since newer versions of IDEA will download the following jars automatically based on the API version used in the project: JUnit platform launcher, JUnit Jupyter engine, and JUnit vintage engine. IntelliJ IDEA releases prior to IDEA 2017.3 bundle specific versions of JUnit 5. Thus, if you want to use a newer version of JUnit Jupyter, execution of the test within the IDE might fail due to version conflict. In such cases, please follow this. In order to use different JUnit 5 version, for example 5.9.0, you may need to include corresponding versions of JUnit platform launcher, JUnit Jupyter engine, and JUnit vintage engine jars in the class path. Here you can see the group ID org.junit.platform in JUnit platform. Here you can see artifact ID as an example. We can consider as artifact ID JUnit platform console standalone, an executable jar with all dependencies included is provided in Maven Central under JUnit platform console standalone directory. This is under group ID org.junit.platform. As an example 4, we can consider artifact ID JUnit platform JFR provides a launcher discovery listener and test execution listener for Java flight recorder events on the JUnit platform. This is in the group org.junit.platform. As an example 5, we can consider JUnit platform reporting artifact. Test execution listener implementations that generate test reports, typically used by IDEs and build tools. This is in group ID org.junit.platform. As an example 6, we can consider artifact ID JUnit platform suite. JUnit platform suite artifact that transitively pulls in dependencies on JUnit platform suite API and JUnit platform suite engine for simplified dependency management in build tools such as Gradle and Maven. This is in the group ID org.junit.platform. As an example 7, we can consider artifact ID JUnit platform suite API. Annotations for configuring test suites on the JUnit platform. This is in group ID org.junit.platform. As an example 8, we can consider JUnit platform suite commons artifact. JUnit platform suite commons support is common support utilities for executing test suites on the JUnit platform. This is in group I under the group ID org.junit.platform. As an example 9, we can consider artifact ID JUnit platform suite engine. Engine that executes test suites on the JUnit platform, only required at runtime. This is in the group ID org.junit.platform. As an example 10, we can consider artifact ID JUnit platform test kit. Provides support for executing a test plan for a given test engine and then accessing the results via a Fluent API to verify the expected results. This is in group ID org.junit.platform. Considering JUnit platform, the legacy XML format in JUnit platform reporting. Legacy XML report generating listener generates a separate XML format for each route and the test plan. Class the legacy XML reporting generating listener in package org.junit.platform.reporting.legacy.xml in module org.junit.platform.reporting. Legacy XML report generating listener is a test execution listener that generate a separate XML report for each route in the test plan. Note that the generated XML format is compatible with the de facto standard for JUnit 4 based test reports that was made popular by Ant build system. The legacy XML report generating listener is used by console launcher as well. Now we are considering Groovy DSL in open test reporting XML format in JUnit platform. For Gradle, writing an open test reporting compatible XML report can be enabled and configured via system properties. The following samples configure its output directory to be the same directory Gradle uses for its own XML reports. The command line argument provide is used to keep the task relocated across different machines, which is important when using Gradle build cache. Is the Groovy DSL, here Kotlin DSL, here the console launcher. When using console launcher, you can enable test reporting output by setting configuration parameters via -- config. Now we are considering required dependencies in setup in JUnit platform suite engine. JUnit platform suite API in test scope artifact containing notification annotations needed to configure a test suite. JUnit platform suite engine in test runtime scope implementation of the test engine API for declarative test suites. Now we are considering a suite example. At suite example, as seen in the following example, selector and filter annotations can then be used to control the content of the suite. Annotation interface at suite in package org.juniorplatform.suite.api in module org.juniorplatform.suite.api. At suite marks a class as a test suite on the JUnit platform. By annotating a class with at suite is marked as a test suite on the JUnit platform. As seen in the following example, select and filter annotations can be used to control the contents of the suite. Additional configuration options. There are numerous configuration options for discovering and filtering tests in test suite. Please consult the Java doc of the org.junior.platform.suite.api package for a full list of supported annotations and further details. Now we are considering engine test kit in JUnit platform test kit. The key entry point into this API is the engine test kit, which provides a static factory method named engine and execute. Class engine test kit in package org.junior.platform.testkit.engine in module org.junior.platform.testkit. The engine test kit provide support for executing a test plan for a given test engine and then accessing the result via a Fluent API to verify the expected results. The org.junior.platform.testkit.engine package provides support for executing test plan for a given test engine running on the JUnit platform and then accessing the result via a Fluent API to verify the expected result. The key entry point into this API is the test engine kit, which provides a static factory methods name engine and execute. It is recommended that you select one of the engine variants to benefit from the Fluent APIs for building a launch discovery request. If you prefer to use the launch discovery request builder for the launch API to build your launch discovery request, you must use one of the execute variants in the test engine. For the sake of brevity, the following how to test the in JUnit Jupyter test engine, whose unique ID engine ID is JUnit-Jupyter. If you want to test your own test engine implementation, you need to use its unique engine ID. Alternatively, you may test your own test engine by supplying an instance of it to the test engine to the engine test kit dot engine test engine static factory method. Now we are considering asserting statistics in JUnit platform test kit. For details on what statistics are available, consult the Java doc for event statistics. The class event statistics in package org.platform.testkit.engine in module org.platform.testkit. Event statistics provides a fluent API for asserting statistics for events. Following test class written using JUnit Jupyter will be used in this example here. One of the most common features of the test kit is the ability to assert statistics against event fired during the execution of a test plan. The following tests demonstrate how to assert statistics for containers and tests in the JUnit Jupyter test engine. For details on what statistics are available, consult the Java doc for event statistics. Here the select the JUnit Jupyter test engine. Select the select example test case test class. Here the execute the test plan, and here the filter by the container events, and here the assert statistics for contain events. Here the filter by here again select JUnit Jupyter engine, Jupyter test engine. Here the select the example test case test class. Hit here the execute the test plan. Here the filter by test events. So and here the assert statistic for test events. In the verify Jupyter container stats methods, test methods, the counts for start and count for the started and succeeded statistics are true, since the Jupyter test engine and the example test case class are both considered containers. sorry, the contain events here, the this one succeed, and here started, and here skipped, and here aborted, and here the following throws an arithmetic exception divided by 0. Now we are considering asserting events. For example, if you want to verify the reason that the skip test method in the example test case was skipped, you can do that as follows. Here the class events in package org.junit.platform.testkit.engine in module org.junit.platform.testkit. Testkit event is a facade that provides a fluent API for working with events. If you find asserting statistic alone is insufficient for verifying the expected behavior for test execution, you can work directly with the recorded event element and perform assertions against them. For example, if you want to verify the reason that the skip test method in the example test case was skipped, you can do that as follows here. The assert that events method in the following example is a shortcut for org.assertj.co.api.assertions.assert that events events list method for list from assert.j assertions library. For details on what conditions are available for use with assert.j assertions against event, consult the Java doc for event conditions. Here the select JUnit Jupyter test engine. Here then here the select the skip test method in the example test example test case test class. Here the execute the test plan. Here the filter by test events. Here the save the test event on to a local variable. And here optionally assert the expected statistics. And here the assert that the recorded test event contain exactly one skip test named skip test with for demonstration purposes as the reason. Now we are considering mandatory requirements in test engines for interoperability with build tools and IDEs. The test engine implementations must adhere to the following requirement. The test descriptor returned from a test engine.discoverer method must be the root of the tree of the test descriptor instances. This implies that there must not be any cycles between a node and its descendants. A test engine must be able to discover unique ID selectors for any unique ID that's previously generated, then returned from the test engine.discoverer. That enables selecting a subset of tests to execute and or return. The execution is skipped, execution started, execution finished methods of the test engine. Execution listener passed to the test engine.execute method must be called for every test descriptor node in the tree returned from the test engine discoverer at most once. Parent nodes must be reported as started before their children and as finished after their children. If a node is reported as skipped, there must not be any events reported for its descendant. An exception example we can consider JUnit exception, class JUnit exception, base class for all runtime exceptions thrown by JUnit. This is in the package org.junit.platform.commons. Now we are focusing on JUnit platform engine, public API for test engines. As an main example, we can consider this segment. Here you can see artifact ID JUnit platform engine. As an example, we can consider package org.junit.platform.engine, public API for test engines. This is in the module org.junit.platform.engine. Engine. And also the module org.junit.platform.engine also public APIs for test engines, provides the test engine interface, test discovery, and execution reporting support. As an example 3, we can consider suit test engine, class suit test engine, the JUnit platform suit test engine. This is in the module org.junit.platform.suit.engine and in the package org.junit.platform.suit.engine. As an example, example 4, we can consider registering test engine. For example, JUnit Jupyter engine module registers its org.junit.jupyter.engine.jupyter test engine in a file named org.junit.platform.engine.test engine within the /meta-inf/ services folder in the JUnit-Jupyter-engine jar. Test engine registration is supported via Java's service loader mechanism. The following example shows how to use org.junit.platform.engine.test engine. Interface test engine. A test engine facilitates discovery and execution of test for a particular programming model. Test engine registration is supported via Java service loader mechanism. Test engine is in module org.junit.platform.engine and package org.junit.platform.engine. Class service loader, a facility to load implementations of a service. Public static service loader load and class loader. Create a new service loader for the given service type and class loader. The service loader class is in module java.base and in package java.util. Here you can see a can be loaded cost in the JVM, and this is in the test class loader, but not available to the class loader. As an example 6, we can consider this. Here the interface configuration parameters that test engines may use to influence test discovery and execution. For example, JUnit Jupyter engine uses a configuration parameter to enable IDE and build tools to deactivate conditional test execution. And optional boolean get boolean string key get the Boolean configuration parameter stored under the specified key. This is in module org.junit.platform.engine and package org.junit.platform.engine. Now we are considering JUnit platform in dependency metadata, and it's the artifact ID JUnit platform engine in group ID org.junit.platform, the public API for test engines. Exception example occurred in as an example, we can consider this code segment, this error information, exception information in the environment JUnit 5 with Eclipse, Java lang no class def found error, etc., and caused by caused by Java lang class not found exception, org.junit.platform.engine.configuration parameters at java.base jdk internal loader built-in class loader class load class built-in class loader.java, etc. As an error example, we can consider this exception in thread main java.lang.bootstrap method error, etc., and then caused by java.lang.no such method error, org.junit.platform.engine.testDescription.prune we add, etc. Now we are focusing on JUnit-platform-launcher, JUnit platform launcher, public API for configuring and launching test plans, typically used by IDEs and build tools. Here you can see the artifact ID platform JUnit platform launcher. This in group ID org.junit.platform. As an additional Gradle dependencies for IntelliJ IDEA, we can consider this code segment as example 2 with Gradle. You can see the artifact ID JUnit platform launcher here. This is in the group ID org.junit.platform. As an example 3, we can consider org.junit.platform.launcher module, public API for configuring and launching test plans. As an example 4, we can consider this code segment regarding discovering tests. Here interface launcher. The launcher API is the main entry point for client code that wishes to discover and execute tests using one or more test engines. Here the test plan discover, launch, discovery request, discover tests and build a test plan according to the supplied launcher the discovery request by querying all the registered engines and collecting their results. This is in module org.junit.platform launcher and package org.junit.platform.launcher. Having test discovery as a dedicated feature of the platform itself frees IDE and build tools from most of the difficulties they had to go through to identify the test classes and test methods in previous versions of JUnit. You can select classes, methods, and all classes in a package, or even search for all tests in a class path or module path. Discovery takes place across all participating test engines. The resulting test plan is a hierarchical and read-only description of all engines, classes, and test methods that fit the launcher discovery request. The client can reverse the tree, retrieve details about a node, and get a link to that original source like class method or file position. Every node in the test plan has a unique ID that can be used to invoke particular test or group of tests. Clients can register one or more launcher discovery listeners, listener implementations via the launcher discovery request builder to gain insight into events that occur during the test discovery. By default, the builder registers an abort on failure listener that aborts test discovery after first discovery failure encountered. The default launcher discovery listener can be changed via JUnit.platform.discovery.listener discovery.listener.default configuration parameter. Here the launcher discovery builder provides a lightweight DSL for generating a launcher discovery request. Here the request create a new launcher discovery request builder. Here the method selectors add all the supplied selectors to the request. Here select package, the static method create package selector for supplied package name. Here select class method create class selector for the supplied class. Here the filters method add all the supplied filters to the request. And here the build the launcher discovery request that has been configured via the builder, via this builder. Launcher session. Here launcher factory a factory for creating launcher instances by invoking create launcher config. Here open session method, public static launcher session open session method, factory method for opening a new launcher session using the default launcher config. Interface launcher session. Here the launcher session API is the main entry point for client's code that wishes to repeatedly discover and execute tests using one or more test engines. Here launcher get launcher get the launcher associated with this session. And here discover additional test plans or execute tests. Here you can see executing test as example 5 here. Here public here void execute launcher discovery request, then execute listeners. This one this method execute test execute a test plan which is built according to the supplied launcher discovery request. By queuing all the registered engines and collecting their results. And here execute test plan, then text execution listeners, execute the supplied test plan, and notify registered listeners about the progress and results the execution. To execute test, client can use the same launcher discovery request. Test progress and reporting can be achieved by registering one or more test execution listeners. Listener implementation with the launcher, as in this example here. There's no return value for the execute method, but you can use text execution listener to aggregate the results. Here the summary generating listener, a simple text execution listener that generates a summary of the test execution. Here register test execution listener method, register one or more listeners for the text execution. Here the launcher here the test plan discover launcher discovery request method, discover test and build a test plan according to the supplied launcher discovery request by querying all registers engines and collecting their results. Here text execution summary, get summary, get the summary generated by the listener, and here text the class the interface text execution summary is a summary of the test plan execution. Here register a listener for your choice. Here discover test and build test plan. Here execute test plan, and alternate to execute the request directly. Here the test plan describes the class test plan. Here the describes the tree of tests and containers as discovered by a launcher. As an example 6, we can consider this one, registering a test engine. For example, JUnit Jupyter engine module registers it org.junit.jupyter.engine.jupyter test engine in a file name org.junit.platform.engine.test engine within the /meta -info /services folder in the JUnit Jupyter engine jar. Test engine registration is supported via Java service loader mechanism. As an example 7, we can consider registering a post discovery filter. For example, an example.custom tag filter class implementing post discovery filter and declared within /meta -inf /services org.junit.platform.launcher.post discovery filter file is loaded and applied automatically. Interface post discovery filter. Post discovery filter is applied to test descriptors after test discovery. In addition to specifying post discovery filters as part of launcher discovery request passed to the launch API, post discovery filter implementations will be covered at runtime via Java's service loader mechanism and automatically applied by the launcher in addition to those that are part of the request. As an example 8, we can consider this code segment registering launcher session listener. The interface launcher session listener register an implementation of this interface to be notified when a launcher session is opened and closed. This in the module org.junit.platform.launcher and package org.junit.platform.launcher. Registered implementation of launcher session listeners are notified when launcher session is opened before launcher first discovered and execute test, and close when no more test will be discovered and executed. They can be registered programmatically via launcher config that is part of the launcher factory, or they can be discovered at runtime via Java's service loader mechanism and automatically registered with launcher session unless automatic registration is disabled. Tool support. Following build tools and IDs are known to provide full support for launcher session, Gradle 4.6 and later, Maven, Surefire, Failsafe 3.0.0, M6 and later, IntelliJ IDEA 2017.3 and later. Other tools might also work but have not been tested explicitly. A launcher session listener is well suited for implementing once per JVM setup teardown behavior, since it's called before the first and after the last test in the launcher session respectively. The scope of the launcher session depends on the used ID or build tool, usually correspond to the lifecycle of the test JVM. A custom listener that starts an HTTP server before executing the first test and stop it after the last test has been executed could look like this. Here you can see step 1 here, start server, and here you can see the export its host address as a system property for consumption by test, and export its port as a system property for consumption by test. And here stopped the HTTP server. The sample uses HTTP server implementation from the JDK HTTP server module that comes with the JDK, but it would work similarly with any other server or resource. In order for the listener to picked up by JUnit platform, you need to register it as a service by adding a resource file with the following name and context to your test runtime class path. For example, by adding the file to source /test/resources. Here source /test/resources meta -info /services org.junit.platform.launcher session listener. and the example.session.global setup tear down listener. Now you can use the resource from your test. Here HTTP tests. Here read the host address of the server from the system property set by the listener, and read the port of the server from the system property by the listener. Send the request to the server and check the status code of the response. And here you can see avoid setup for test discovery by delaying until tests are about to be executed. Registering launcher discovery listener. The interface launcher discovery listener register a concrete implementation of this interface with the launcher discovery request builder or launcher to be notified events that occur during the test discovery. This is in the module org.junit.platform.launcher and package org.junit.platform.launcher. Here in addition to specifying discovery listeners as a part of launcher discovery request or registering them programmatically via the launcher API, custom launcher discovery listener implementations can be discovered at runtime via Java service loader mechanism and automatically registered with the launcher created via launcher factory. For example, an custom launcher discovery listener class implementing launcher discovery listener and declared within /meta-info/services org.junit.platform.launcher discovery listener file is loaded and registered automatically. As an example 10, we can consider registering test execution listener. For example, an example.custom test execution listener class implementing test execution listener and declared within the /meta-info/services org.junit.platform.launcher.test execution listener file is loaded and registered automatically. The interface text execution listener register a concrete implementation of this interface with a launcher to be notified of event that occur during test execution. This is in the module org.junit.platform.launcher and package org.junit.platform.launcher. Here, in addition to launcher API method for registering test execution listeners programmatically, custom test execution listener implementation will be discovered at runtime via Java's service loader mechanism and automatically registered with the launcher created via launcher factory. As an example 11, we can consider JUnit.platform.execution.listener.deactivate. Here, deactivating a test execution listener. Sometimes it can be useful to run a test suite without certain execution listeners being active. For example, you might have a custom test execution listener that sends the test results to an external system for reporting purposes. And while debugging, you might not want these debugging results to be reported. To do this, provide a pattern for JUnit.platform.execution.listener.deactivate. Configure a parameter to specify which execution listeners should be deactivated that is not registered for the current test run. only listeners registered via service load mechanism within /meta-inf/services/org.juni.platform.launcher.test unit test execution listener file can be deactivated. In other words, any test execution listener registered is explicitly via launcher discovery request cannot be deactivated via the JUnit platform.execution.listeners.deactivate configuration parameter. In addition, since execution listeners are registered before the test run starts, the JUnit.platform.execution.listeners.deactivate configuration parameter can only be supplied as a JVM system property or via the JUnit platform configuration file. This configuration parameter cannot be supplied in the launcher discovery request that is passed to the launcher. As an example 12, we can consider configuring the launcher. The interface launcher config defines the configuration API for creating launcher instances via the launcher factory. This is in the module org.junit.platform.launcher and package org.junit.platform.launcher.core. If you require fine-grained control or automatic detection and registration of test engines and listeners, you may create an instance of launcher config and supply that either to the launcher factory. Typically, an instance of a launcher config is created via the built-in Fluent builder API as demonstrated in this example here. Here, launcher config the builder create a new launcher config builder. Here the method test engine enable test engine auto registration in launcher config.builder class. Configure the auto registration flag for test engines. Here the enable launcher session listener auto registration. Configure the auto registration flag for the launcher session listeners. Here enable launcher discovery listener auto registration. Configure the auto registration flag for launcher discovery listeners. Here enable post discovery filter auto registration. Configure the auto registration flag for the post discovery filters, and here enable text execution listener auto registration boolean. Configure the auto registration flag for the test execution text listeners. Here add test engines. Add all the support supply test engines to the configuration. Here add launcher session listeners. Add all the supplied launcher session listeners to the configuration. Add launcher discovery listeners. Add all the supplied launcher discovery listeners to the configuration. Add post discovery filters. Add all the supplied filters to the configuration and add test execution listeners. Add all the supplied test execution listener to the configuration. And the build the launcher config that has been configured via the builder. As an example, now we are considering a usage example in discovering testing JUnit platform launcher API. Launcher discovery request. The interface in package org.jmut.platform.launcher in module org.jmut.platform.launcher. The launcher discovery request extend the engine discovery request API with additional filters that are applied by the launcher itself. Having test discovery as a dedicated feature on the platform itself frees the IDEs and build tools from most of the difficulties they had to go through to identify test classes and test methods in previous versions of JUnit. You can select classes, methods, and all classes in a package. Or even search for all tests in a class path or module path. Discovery takes a place across all participating test engines. Resulting test plan is a hierarchical read-only description of all engines, classes and test methods that fit the launcher discovery requests. The client can traverse the tree, retrieve details about the node, and get a link to the original source like class, method, or file provision. Every node in the test plan has a unique ID that can be used to invoke a particular test to a group of tests. Clients can register one or more launcher discovery listener. Implementations via launch discovery listener, launch discovery request builder to gain insight into events that occur during test discovery. By default, the builders registers a abort on failure listener that aborts the test discovery after first discovery failure is encountered. The default launcher discovery listener can be changed via the JUnit.platform.discovery.listener.default configuration parameter. Discover additional test plans or execute tests. Now we are considering executing tests. Test progress and reporting can be achieved by registering one or more test execution listener. Implementation with the launcher as in the following example. The interface launcher in module in package org.jmut.platform.launcher in module org.jmut.platform.launcher. The launcher API is the main entry point for client code that wishes to discover and execute tests using one or more test engines. Here the void execute launcher discovery request Here the launcher discovery request execution listeners execute the test plan, which is built according to the supplied launcher discovery request by querying all the registers engines, collecting their result, and notify the registers listeners about the progress and result of the execution. Void execute test plan execution listeners execute the supply test plan and notify the registers listeners about the progress and the result of the execution. To execute test, client can use the same launcher discovery request. As in a directory page, so create a new as in the discovery page, so create new request. Test progress and reporting can be achieved by registering one or more text execution listener. Test execution listener implementation with launcher, as in the this example. There is no return value for the execute method, but you can use test execution listener to aggregate the result. For example, see summary generating listener, legacy XML report generating listener, and unique ID tracking listener. All test execution listener methods are called sequentially. Methods for start events are called the registration order, while methods for finish events are called in the reverse order. Test case execution won't start before all execution started calls have returned. Register a listener of your choice. Discover, test, and build a test plan. Execute test plan. Alternatively, execute the request directly. Do something with the summary. Now we are considering registering a test engine. Here the registering test engine registration is supported by Java service loader mechanism. Here the class service loader type parameters in package java.util, in module java.base, a facility to load the implementation of a service. Now we are considering registering a post-discovery filter. In addition to specifying post-discovery filters as part of launcher discovery request passed to the launcher API, post-discovery filter implementation will be discovered at runtime via Java service loader mechanism and automatically applied by the launcher in addition to those that are part of the request. Interface post discovery filter in package org.generalplatform.launcher, in module org.generalplatform.launcher. A post discovery filter is applied to test descriptors after test discovery. For example, an example.custom tag filter class implementing post discovery filter is declared within meta dash in inf /services dot org dot JUnit dot platform dot launch dot post discovery filter file is loaded and applied automatically. Now we are considering usage example usage in registering a launch session listener, a custom listener that starts HTTP server before executing the first test and stop after the last test has been executed could look like this. The interface launcher session listener in package org.JUnit.platform.launcher in the module org.JUnit.platform.launcher register an implementation of this interface to be notified when a launcher session is opened and closed. Launcher session listener is well suited for implementing once per JVM setup and tear down behavior since it's called before the first and after the last test in the launcher session respectively. The scope of a launcher session depends on the IDE, the used IDE or build tool what usually correspond to the lifecycle of test JVM. A custom listener that start an HTTP server before executing the first test and stop after the last test has been executed. This could like this. Here the started the HTTP server. Here the export the host address as system property for consumption by tests. Here the export its port as a system property for consumption by tests. Here the stop the HTTP server. This example is a HTTP server implementation from the jdk.http server module that comes with the JDK but would similarly with any other server or resource. In order for the listener to be picked up by the JUnit platform, you need to register it as a service by adding the resource file while following the name and content to your test runtime class path. For example, by adding the source file to src/test for src for resources. For src/test/resources/meta-inf/services/org.junit.platform.launcher session listener. Here the added line. Now you can use the resource from your test. Here here the read the host address and the server address and the server from the system property set by the listener. Read the port of the server from the system property set by the listener, and here the send a request to the server. Here the check the status code of the response. Avoid setup for test discovery by delaying it until tests are about to be executed. Now we are considering registering in launcher interceptor. In order to intercept creation of instances of launcher and launcher session listener and calls the discover and execute method of the former, and client can register custom implementation of launch interceptor via Java service loader mechanism by adding the setting. Additionally, setting the join.platform.launcher.interceptor.enabled configuration parameter to true. A typical use case is to create a custom replace for class loader used by the JUnit platform to load classes and engine implementations. Now we are considering registering a launcher discovery listener. For example, an example dot custom launcher discovery listener class implementing launcher discovery listener and declared within the /meta-info/services/org.jun.platform.launcher.launcher discovery listener. File is loaded and registered automatically. In addition to the specifying listeners as part of the launcher discovery request to registering them programmatically via launch API, the custom launcher discovery listener implementations can be discovered at runtime via service loader mechanism and automatically registered with the launcher created via launcher factory. The interface launcher discovery request in package org.jun.platform.launcher in launch module.org.jun.platform.launcher. Launcher discovery request extend the discovery engine discovery request API with additional filters that are supplied by the launcher itself. Now we are considering registering a test execution listener. For example, an example.custom test execution listener class implementing test execution listener and declared within the /meta-info services org.jun.platform.launcher.txt execution listener file is loaded and registered automatically. The interface test execution listener in package org.jun.platform.launcher in module org.jun.platform.launcher register concrete implementation of this interface with the launcher to be notified of event that occur during test execution. In addition to the public launcher API method for registering test execution listeners programmatically, custom test execution listener implementation will be discovered at runtime via Java service loader mechanism and automatically registered with this launcher created via the launcher factory. Now we are considering configuring a test execution listener. The listener can then access the configuration parameters via the test plans applied to the test plan execution started test plan and test plan execution finished test plan callback methods interface test execution the method default void test plan execution started test plan in interface test execution listener in package org.jmdot.platform.launcher in module org.jmdot.platform.launcher called when the execution of a test plan has started and before any test has been executed. When a test execution listener is registered programmatically via the launch API, the listener may provide programmatic ways for it to be configured, for example, via its constructor, setup methods, etc. However, when the test execution listener is registered automatically via the Java service locator loader mechanism, there is no way for the user to directly configure the listener. In such cases, the author of the test execution listener may choose to make the listener configurable via configuration parameters. Listener can then access the configuration parameters via test plans applied to the test execution started test plan and test execution finished test plan callback methods. See the now we are considering deactivating test execution listener. To do this, provide the pattern for the JUnit platform.execution.listeners.deactivate configuration parameter to specify which execution listener should be deactivated that is not registered for the current test run. Sometimes it can be useful to run a test suite without certain execution listeners being active. For example, you might have a custom test execution listener that sends the test results to an external system for reporting purpose, and while debugging you might not want the debug result to be reported. To do this, provide the pattern for JUnit.platform.execution.listeners.deactivate configuration parameter to specify which execution listener should be deactivated that is not registered for the current test run. Only listeners registered via service loader mechanism with the method /method inf services org.jmdot.platform.launcher.test execution listener file can be deactivated. In other words, any test execution listener registered explicitly via launcher discovery request cannot be deactivated via JUnit.platform.execution.listeners.deactivate configuration parameter. In addition, since execution listeners are registered before the test run restarts, JUnit.platform.execution.listener.deactivate configuration parameter can only be supplied as a VM system property or via JUnit platform configuration file. This configuration parameter cannot be supplied at the launcher discovery request that is passed to the launcher. Now we are considering configuring the launcher. Typically, an instance of launcher config is created via the built-in Fluent Build API as demonstrated in this example. The interface launcher config in package org.jmdot.platform.launcher.co in module org.jmdot.platform.launcher. Launcher config defines the configuration API for creating launcher instances via the launcher factory. If you require fine-grained control over automatic detection and registration of test engines and listeners, you may create an instance of launcher config and supply that to the launcher factory. Typically, an instance of launcher config is created via the built-in Fluent Builder API as demonstrated in this example. Now we are considering dry run mode. When running test via the launcher API, you can enable dry run mode by setting the JUnit.platform.execution.dryrun.enabled configuration parameter to true. In this mode, the launcher will not actually execute any test that will notify registered execute any test, but will notify test execution listener instances as if all test has been skipped and their container has been successful. This can be useful to test changes in the configuration of build and to verify the listener is called as expected without having to wait for all tests to be executed. Now we are considering the use of Maven Surefire failsafe 3.0.0 M4 or later to avoid interoperability issues in Maven in build support in running tests. Maven Surefire or failsafe 3.0.0 M4 introduce support for aligning the version of the JUnit platform launcher. It uses the JUnit platform version found on the test runtime class path. Therefore, it is recommended to use version 3.0.0 M4 or later to avoid interoperability issues. Alternatively, you can add the test dependency on the matching version of the JUnit platform launcher to your Maven build as follows here. Now we are considering JUnit platform in dependency metadata. The artifact ID JUnit platform launcher in group ID org.junit platform. Public API for configuring and launching test plans typically used by the IDEs and build tools. You can consider this one occurred in IntelliJ and Spring Boot 2.3.9. Failed to resolve JUnit platform launcher 1.6.3 IntelliJ. Now we are focusing on JUnit-platform.runner. JUnit platform runner for executing test and test suites on JUnit platform in a JUnit 4 environment. And here you can see the runner hierarchy. A runner has to implement two methods of defining the cooperation policy with the tool's runtime instance. The first is get description. It is inherited from its super interface describable and returns the instance of the description. The description is used to provide human readable information about the test which is to be run or has been run. It can describe single test, atomic, or a hierarchy of test compound. The information provided by each runner is used, for example, by GUI to depict all test that particular launch effects. The second method is called run, and it takes run notifier as an argument. This is, of course, where all the action happens. Here the runner is supposed to select the executables of test case, invoke them and report appropriate state information using notifier callback. We will provide more insight into this in a minute when we write our own implementation. Runner has to be abstract class. It supplies the convenient test count method. The latter provides the number of tests to be run, calculate on the information returned by get description. This enables subclasses to override the computation for unusual demand, but probably only seldom makes sense. At tiny rate, this base class is the way to go if you need functionality that differs significantly from the common use cases. More likely though is that one will extend parent runner T a subclass runner This implements the policy described earlier by delegating a few abstract methods, essentially an interior works on a list of children. The child is a generic type T. The list of T might be the test defined by a single test case. It should be derived from the constructor injected test class. Development needs are reduced to retrieve this list of children. And to provide description and execution of a single child. Parent runner class itself is responsible, among other things, for invoking the at before class and at after class annotated methods, creating a composite description and running children sequentially. The annotations are meant to share expensive fixture setups among the children. Thus marked method get only called once, namely after entirely of child executions. We are already aware of the block JUnit 4 class runner extension, which is used as a standard JUnit test case processor. Following diagram also contains another execution called suit that will cover the suit. And other than once mentioned, the class hierarchy contains two interfaces declaring filtering and sorting capabilities implemented by parent runner. But before here the this runner implements a describable interface, and parent runner T implements the filterable and sortable, and implements runner. And here the suit and block JUnit for class runner is connected to parent runner here. As an example, in Maven we can consider this segment. Here you can see the artifact ID JUnit platform runner. This is in the group ID org.junit.platform. As an example 2, we can consider module org.junit.platform.runner and annotations for configuring and executing test on the JUnit platform in JUnit 4 environment. As an example 3, we can consider using JUnit 4 to run JUnit platform single test class JUnit platform JUnit 4 based runner, which runs test on the JUnit platform in JUnit 4 environment, deprecated since 1.8 in favor of the suit support provided by the JUnit platform suit engine module, to be removed in JUnit platform 2.0 module. It is in the module org.junit.platform.runner package org.junit.platform.runner. Here one way to use the JUnit platform runner is to annotate a test class with ampersand run with JUnit platform.class directly. Please note that the test methods with the following examples are annotated with org.junit.jupyter.api.test JUnit Jupyter, not org.junit.test JUnit 4. Moreover, in this case, the test class must be public. Otherwise, some IDs and build tools might not recognize it as a JUnit 4 test class. The JUnit platform runner has been deprecated. The JUnit platform runner was developed by JUnit team as a interim solution for running test suites and test on the JUnit platform in a JUnit 4 environment. In recent years, all mainstream build tools and IDEs provide built-in support for running tests directly on the JUnit platform. In addition to the introduction of ampersand suite support by the JUnit platform, suite engine modules make the JUnit platform runner obsolete. The JUnit platform runner and ampersand use technical names annotation have therefore been deprecated in JUnit platform 1.8 and will be removed in JUnit platform 2.0. If you are using JUnit platform runner, please migrate to ampersand suite support. JUnit platform runner is a JUnit 4 based runner which enables you to run tests whose programming model is supported on the JUnit platform in a JUnit 4 environment. For example, JUnit Jupyter test class. Annotating the class with run with ampersand run with and JUnit platform.class allows it to be run with IDEs and built systems that support JUnit 4 but not yet support the JUnit platform directly. Since JUnit platform has features that JUnit 4 does not have, the runner is only able to support subset of JUnit platform functionality, especially with regard to reporting. The annotation type run with, when a class is annotated with ampersand run with or extend the class annotated with ampersand run with, JUnit will invoke the class it references to run the test in that class instead of the runner built into JUnit. We added this feature late in the development. While it seems powerful, we expect the runner API to change as we learn how people really use it. Some of the classes that are currently internal will likely be refined and become public. For example, suites in JUnit 4 are built using run with and a customer runner name suite. This description is with JUnit 4. So we can consider this code segment as example 4. Using JUnit 4 to run the JUnit platform test suite. If you have multiple test classes, you can create a test suite as can be seen in the following example. The annotation interface select packages. Ampersand select packages specifies the names of packages to select when running a test suite on the JUnit platform. Using the module org.junit.platform.suite.api and package org.junit.platform.suite.api. Ampersand suite display name is used to declare custom display name for the annotated test class that is executed as a test suite on the JUnit platform. As an example 5, we can consider this. Using JUnit 4 to run the JUnit platform setup, you need the following artifacts and their dependencies on the class path. Explicit dependencies: JUnit platform runner in test scope, location of the JUnit platform runner, JUnit 4.13.2.jar in the test scope to run the test using JUnit 4, JUnit Jupyter API in the test scope, API for writing test using JUnit Jupyter, including ampersand test, etc. JUnit Jupyter engine in test runtime scope, implementation of test engine API for JUnit Jupyter, transitive dependencies, JUnit platform suite API in test scope, JUnit platform suite commands in test scope, JUnit platform launcher in test scope, JUnit platform engine in test scope, JUnit platform commands in test scope, open test 4j in test scope. Now we are considering explicit dependencies in setup in using JUnit 4 to run the JUnit platform. JUnit platform runner in test scope, location of the JUnit platform runner, JUnit here the 4.13.2.jar in test scope to run JUnit test using JUnit 4. JUnit Jupyter API in test scope, API for writing test using JUnit Jupyter including at test etc. JUnit Jupyter engine in test runtime scope, implementation of the test engine API for JUnit Jupyter. Now we are considering display names versus technical names. To define the custom display name for test class, run via run with JUnit platform.class, annotate with the class at display name and provide the custom value. The annotation interface suit display name in package org.generator.platform.suite.api, in module org.generator.platform.suite.api. At suite display name is used to declare a custom display name for annotated test class that is executed as a test suite on the JUnit platform. Annotation interface technical, use technical name in package org.generator.platform.suite.api, in module org.generator.platform.suite.api. It's deprecated since 1.8 in favor of the at suite support provided by the JUnit platform suite engine module to be removed from in the JUnit platform 2.0. At use technical names, specify that technical name should be used instead of display names when running test suite on the JUnit platform. By default, display names will be used for test artifact. However, when the JUnit platform runner is used to execute test with the build tool such as Gradle or Maven, the generated test report often needs to include the technical names of the test artifacts. For example, fully qualified class names instead of shorter display names like simple name of a test class or custom display name containing special characters to enable technical name for reporting purposes. Declare at use technical names annotation alongside run with JUnit platform.class. Note that the presence of at use technical names overrides any custom display name configured via at suite display name. Now we are considering single test class. Moreover, with this case, the test class must be public. Otherwise, the some IDs and build tools might not recognize it as a JUnit 4 test class. The annotation type run with org.generator.runner, in this is in the version 4. When the class annotated with at run with, then extend it. The class annotated with at run with, the JUnit invoke the class references to run the test in that class instead of the runner built into JUnit. We added this feature late in development. While it seems powerful, we expect the runner API to change as we learn how people really use it. Some of the classes that are currently internal will likely be refined and become public. For example, suite in JUnit 4 are built using run with and custom runner named suite. One way to use the JUnit platform runner is to annotate the test class with at run with then JUnit platform.class directly. Please note that the test method in this example are annotated with JUnit org.generator.jupyter.api.test JUnit Jupyter, not org.generator.test in JUnit 4. Moreover, in this case, the test class must be public. Otherwise, the some IDs and build tools might not recognize it as a JUnit 4 test class. no op. Now we are considering test suite. If you have multiple test classes, you can create test suite as test suite as can be seen in this example. The annotation type select packages. In package org.generator.platform.suite.api module org.generator.platform.suite.api at select packages specify the names of the packages to select when running a test suite in the JUnit platform. If you have multiple test classes, you can create test suite as can be seen in this example. The JUnit platform suite demo will discover and run all tests in the example package in its sub packages. By default, it will only include test classes whose names either begin with test or test or end with test or tests. Additional configuration options. There are more configuration options for discovering and filtering test than select packages. Please consult the java doc of org.generator.platform.suite.api package for further details. The test class and suites annotated with run with JUnit platform dot class cannot be executed directly on the JUnit platform or as a JUnit 5 test as documented in some IDEs. Such classes and suites can only be executed using JUnit 4 infrastructure. Now we are considering the artifact JUnit platform in dependency metadata. Artifact ID JUnit platform runner in group ID of the JUnit platform runner for executing test and test suites on the JUnit platform as in JUnit 4 environment. As an example, we can consider this no test remain exception. Can be occurred in method void public void filter in class JUnit platform. As an example, we can consider this occurred in environment with Eclipse and Maven. Package org.junit.platform.runner does not exist, etc. Now we are focusing on JUnit platform Surefire provider. JUnit platform Surefire provider, which provides a support for discovering and executing tests on the JUnit platform by using Maven Surefire. As an example in Maven, we can consider this one. Artifact ID JUnit platform Surefire provider, the group ID org.junit.platform. The JUnit platform Maven Surefire provider has been discontinued. The JUnit platform Surefire provider, which was originally developed by the JUnit team, was deprecated in JUnit platform 1.3 and discontinued in 1.4. Please use Maven Surefire native support instead. Starting with version 2.22.0, Maven Surefire and Maven failsafe provide native support for executing tests on the JUnit platform. The pom.xml file in the JUnit Jupyter Starter Maven project demonstrate how to use Maven Surefire plugin and can serve as a starting point for configuring your Maven build. As an example too, we can consider package org.junit.platform.surefire.provider, Maven Surefire provider for JUnit platform. As an example 3, we can consider this the Maven, this Maven segment. Here you can see JUnit platform Surefire provider here. Here you can see the Maven Surefire provide in build support in running test. In here the use of configuration parameters property. Now we are focusing on JUnit Platform Gradle plugin. JUnit Platform Gradle plugin, which provides support for discovering and executing tests on the JUnit platform by using Gradle. The JUnit Platform Gradle plugin has been discontinued. The JUnit Platform Gradle plugin developed by the JUnit team was deprecated in the JUnit Platform 1.2 and discontinued in 1.3. Please switch to Gradle standard test task. As an example, we can consider this. Here you can see artifact ID JUnit Platform Gradle plugin. Here it's under group ID org.junit.platform. As an error example, we can consider this error occurred in environment Gradle version 4.0. Plugin with id org.junit.platform.gradle.plugin not found. Platform console. Support for discovering and executing tests on the JUnit platform from the console. Here you can see the artifact JUnit platform console, the group ID org.junit.platform. As an example too, we can consider org.junit.platform.console module, support for launching the JUnit platform from the console. As an example 3, you can also run the standalone console launcher as shown here. For example, to include all jars in a directory. Yeah. Exit code, the console launch exit with the status code of 1 if any containers or test fails. If no tests are discovered and the --fail if -no -test command line option is applied, the console launcher exits with the status code of 2. Otherwise, exit code is 0. The class console launcher. The console launcher is a standalone application for launching JUnit platform from the console. It's in the module org.junit.platform.console and package org.junit.platform.console. The console launcher is a command line Java application that lets you to launch the JUnit platform from the console. For example, it can be used to run JUnit vintage and JUnit Jupyter test and print test execution results to the console launcher. Argument files, ampersand files. If an argument contains embedded white space, the whole argument should be wrapped in a double or single quotes, for example. And options selectors -f or --select -file equal file. Select file for test discovery. This option can be repeated. On some platforms, you may run into system limitation of length of the command line when creating command line with lot of options, so with long argument. Since version 1.3, the console launcher supports argument files, also known as ampersand files. Argument files are files that themselves contain arguments to be passed to the command. When the underlying Uh, Picocly command line pass encounters an argument beginning with the character ampersand. It expands the contents of that file into the argument list. If the argument file does not exist or cannot be read, the argument will be treated literally and will not be removed. This will likely result in unmatched argument error message. You can troubleshoot such errors by executing the command with the picocli.trace system property set to debug. Multiple ampersand files may be multiple @signs may be specified on the command line. Specified path may be relative to the current directory or absolute. You can pass real parameter with the initial @character by escaping with the additional @symbol. For example, at some mark will become @some mark and will not be subject to expansion. As an example 5, we can consider color customization, the console launcher. The properties file here demonstrate the default style. The single color style test output using only text attributes, no color, not supported by all terminals. Color palette equal file specify a path to a properties file to customize and see style of output, not supported by all terminals. The colors used in the output of the console launcher can be customized. The option single color will apply a built-in monochrome style, while color palette will accept the properties file to override NC SGR color styling. The properties file here demonstrate the default style here. Successful equal 32, aborted equal 33, failed equal 31, skipped equal 34, 35, container equal 35, test equal 34, dynamic equal 35, and reported equal 37. Now we are considering class console launcher in package or JUnit.platform.console in module log.JUnit.platform.console. The console launch is a standalone application for launching the JUnit platform from the console. Here we are considering console launch in running test. You can run the standalone console launch as shown here. The console launch is a command line Java application that lets you launch the JUnit platform from the console. For example, it can be used to run JUnit Vintage and JUnit Jupyter test and print test execution results to the console. The executable JUnit platform console is standalone 1.10.0.jar with all dependencies included is published in Maven Center repository under JUnit platform console standalone directory. You can run the standalone console launcher as shown here. You can also run the standalone console launcher as shown here, for example, to include the old jars in a directory. Exit code, the console launcher exit with the status code of 1 if any containers or tests failed. If no tests are discovered and the fail if no test command line option is applied, the console launcher exit with the status code of 2. Otherwise, exit code is 0. JUnit, now we are considering subcommands and options. The console launcher provides the following subcommands. Now we are considering argument file at dash files. If an argument contain embedded white space, the whole argument should be wrapped in double or single quotes. For example, here dash f equal my space files /stuff.java double quotation here. On some platforms you may run into system limitations on the length of the command line and creating command line with a lot of options, so with long arguments. Since version 1.3, the console launcher support argument files, also known as at dash files. Argument files are files that themselves contain argument to be passed to the command. When underline Piccoli command line parser encounters an argument beginning with the character at, it expands the content of the file into argument list. Arguments within a file can be separated by spaces or new lines. If an argument contains embedded white space, the whole argument should be wrapped in double or single quotes, for example, like here. If the argument file does not exist and cannot be read, the argument will be treated literally and will not be removed. This will likely result in an unmatched argument error message. You can troubleshoot such errors by executing the command with piccoli.trace system property set to debug. Multiple at dash files may be specified on the command line. The specified path may be relative to the current directory or absolute. You can pass the real parameter with an initial at character by escaping it with the additional at symbol. For example, at sumarg will become at sumarg and will not be subject to expansion. Now we are considering color customization. The colors used in output of the console launcher can be customized. The option color single color will apply a built-in monochrome style, while color palette will accept the properties file to override SGR color styling. The properties file below demonstrate the default style. And now here we are considering JUnit open test reporting console launcher in open test reporting XML in JUnit platform reporting. When using the console launcher, you can enable open test reporting output by setting the configuration parameter via dash config here. Now we are considering the JUnit platform in dependency metadata. The artifact ID JUnit platform console in group ID org.junit.platform. The support for discovering and executing tests on the JUnit platform from console. This occurred in the environment with 5.0.0 and operating system and version Mac OS X 10.15.7 Catalina x86-64 build tools Gradle 6.8.3 Kotlin 1.4.30 JVM 11.0.10 and this is caused by Java lang. The console launcher test failed. Error could not find or load main class org.junit.platform.console.console launcher caused by java.lang.console class not found exception org.junit.platform.console.console launcher. Follow the steps for readme .md cucumber junit platform engine. Step 2, assume incorrectly that only dependency needed is org.junit.platform colon JUnit platform launcher :xyz run /gradle w clean test and observed error. As an error example, we can consider this occurred in the environment with JMeter and MSSQL-JDBC. Failure to find org.JUnit.platform JUnit platform console jar in https://repo.maven.apache.org./maven. was cached in the local repository. Resolution will not be reattempted until the update interval of central has lapsed or updates are forced.